Okay, so we're going to move forward and discuss business process intelligence and new strategies and tools that carriers can employ for that. We have three men joining us today, and I'm just going to turn it over to Tom Wisnowski. He's the Chief Strategist at Kansys. So please welcome Tom, and Tom will introduce the other two.
Thank you, Tim. Good afternoon, everyone. It's post-lunch. Hopefully everyone didn't overindulge. But our goal here today is to share a little bit about the history of who we are as two companies, how we came together, the history of what we've done in the space, and hopefully at the end of it we'll entertain you guys enough so that you'll learn something when you walk back out the doors. But as Tim said, I'm Tom Wisnowski with Kansys, charge of strategy, design, information, being out on the front foray of where the market is headed, having conversations with people like yourselves, understanding what your pain points are, what your problems are, and how you're investigating the technologies that can remove them for you to gain additional revenues and provide a better experience for your subscribers. Got Brian Preston, who's also with Kansys, been with the company for 15 years since we founded. Brings quite a lot of experience to the table relative to programming. He's a data analyst, a data scientist, and a process methodology guy that is second to none. Chris Knight is a VP of Product Management and Sales Engineering for our partner company, our partner arrangement, I should say, independently owned. But Series and Kansys formed a partnership a little bit over 3 years ago. And Chris and Brian and myself have spent a lot of time over the last several months crafting solutions for providers in the mobile space. So a little bit about Series. They're headquartered down in Richardson, Texas, suburb in Dallas. They have a product that they've developed and designed from the ground up called Maestro. It's a signaling and data controller product. It's very nimble, very easy to interact with from a user interface. So as you go out and you build these process needs and the workflow behind them, it's a very intuitive way to go out and build the decision matrices required to capture the information and turn it into actionable revenue and actionable items for your subscribers. They have offices in Bolivia, Mexico, and Russia. I think Russia is where they have a lot of their development team and some of their analysts over there. With a mission, simple in its statement, extremely powerful, orchestrate data, harmonize the data within the networks. They have a strategy that go to market with their channel partners, which we are one of, and other SIs that they've built and developed relationships with. And as you can see, they have a very large, diverse group of subscribers that they support with their technology today. A bit about Kansys. We're in our 16th year of operation, started in '97. A company out of Olathe, or as some folks like to call it, Olathe, but I assure you it's Olathe, Kansas. We're a southwestern suburb of Kansas City. Come from a diverse background of operations in wireline telco, and have grown over that 15-year span and expanded that operations model into data analytics, custom software development at the application layer, as well as reaching out into the network layer to absorb all of those transactions that happen out on your guys' owned entities. Our strategy in dealing with our clients is there's a time to answers model that we go to try and strive and deliver, whether that be via services or hosted application layer, that gives you answers to all the information that is swirling in your network about your customers and all the entitlements and the devices that they use in your network. We aggregate that into our network operations center and provide those answers to you in very simple web-based interface, as well as services contracts associated with support and design. So how did this partnership between Series and Kansys really kind of materialize? Well, it was just down the street about 3 years ago at the Bellagio. A good friend of mine introduced me to this company, Series, and he talked about this engine that they were building that would be very complementary to our back office analytics, reporting, and analysis. I said, okay. And now 3 years later, We have a partnership established, multiple projects in the queue right now that we're working on, some of which you'll hear about in some use cases today. So the solution overview kind of looks like a busy diagram. Series built the logic for a real-time policy engine, real-time charging functionality. They have built the connectors to the devices out in the networks. They can talk to the data stores where they live and push that information up to the application layer. And quite simply, all of these different service types that exist out in your network today, there's different devices, there's different consumers, so there's different expectations from the devices and from those that use the devices on your network. So we've come up with a go-to-market strategy. When you glue the piece over here with Kansys, which is the aggregation of that information into a single subscriber profile repository that can drive output and dynamic visualization that will allow you as a C-level, a managerial level, and down here at the operations level to understand how does this information correlate? What are the devices and how those services that are provisioned on those devices, what are they really telling me about the services that I'm delivering to my end subscribers? And oh, by the way, how can I do that in a more efficient cost model for my operating expenses, and at the same time, capture revenue against those demanding services that my customers with all those smartphones in their pockets are asking about. So we've come up with a product that we're calling a converged policy as a service and a converged charging as a service. And together, we can offer that solution, and we'll show you examples of where it works, to be able to minimize the cost associated with infrastructure build-out to support it, the people to deploy it and manage it, and in a single converged predictable cost model. So that said, I'm going to turn it over here to Brian Preston, who's going to talk a little bit about the Kansys side and how we bring the events together into the visualization layer and the policy and workflow rules that back it up.
Thanks, Tom.
Thank you, Ben.
Hi, I'm Brian Preston with Kansys. To kind of carry on the conversation that we're having here that Tom introduced to us, the CPaaS, the Converged Charging as a Service, and the Policy Management Engine is an offshoot of the years that we spent in an analytics side, servicing our customers, our clients, the carriers that we service, giving the reports and the data, mining it for them, giving them the reports, supporting the different business units, helping them monetize, marketing offerings, utilization of network capacity, all the things you do on a day-to-day basis to kind of support it in the back office, to push the data up to the front office so people can understand how well are we doing, does this make sense, have we spent right money here, wrong money there, what do we need to do, how do we correlate that data? One of the challenges we've had as a data processing and a mediation data aggregation support company for our customers, our clients, was the quality of the data and the timeliness of the data. When can we get it? How well is it going to work? And what do we need to gap fill with that data? Where's the missing holes in it? So at some instances, some data may come to you in batch, takes a long time, it's 30 days out. I'm looking for real time. I want to find out who did what. I've got a marketing plan out here. I've turned up new customers. They're utilizing these services. What do you mean it's going to take me 30 days to get the data back to figure out what's going on? Why can't I get into that information a little easier? Well, we peeled back the layer on some of our pain points and challenges based on what our customers were looking for. Our customers are our clients. And we found out, well, one of the problems is if you're going to do it real time, you got to have real time access to the data. So depending on the network infrastructure they had in place, data may or may not be available to you at a real time level. Or they've got legacy equipment that kind of has it there, but they're not quite able to get the data out in a timely manner, not without expending a lot of extra money, extra coding time, extra processes in place, management, et cetera. So we came up, and when we met with Series, was to discuss that very issue. How can we converge the different network elements, push that data out quickly into the business space, visualize that, make it be actionable information to the user community, and then at the same time, turn right around and make that data go back so it can affect the service logic at the transaction layer in the network elements. So what we'll move into is maybe a couple of examples that kind of help show what we were talking about doing here. One of the first examples is the utilizing this technology for international fraud management and control. So you've got people that are making international calls. One of the tough things to do is the definition of fraud protection or abuse detection versus stopping it before it happens or responding to it after you've already been dinged. So you find out that for the last 2 weeks, you've been getting hit by XYZ calling pattern, whatever the case may be. How do I find out, how do I trigger those metrics to figure out, set that alarm, shut it off before it happens, or slow it down on the fly? So our company, as Kansys, is having had the data and the processing, we're able to run the reports. As soon as we can get the data, we can figure out what's going on. But the problem is, once we get that, we don't have a mechanism to push it back. We need to be able to trigger that, make that happen real time, based on policy rules that you as a carrier would come up with and say, I'm willing to take this much risk. When it gets to this point, I want you to cut it off, or I want you to slow them down. So put some media in there, do something, whatever the case may be. You get to control those logic rules. So as an extension of that, the way we do this is we build out the user interfaces to allow you to configure this simply yourself, your own customers, your own employees, your own business units, whether it's your revenue assurance group, whether it's fraud abuse, whichever business functionality makes sense to manage it. Take the data points that are provided to you in an interface, configure the rules on the fly. You don't need to code for all this. It should be trigger-based so that once you set it up and define those parameters and those rules, that should flow back and be actionable at the network layer to stop it on the fly. It's not a special system. It just makes sense. If I know this number, if I hit this threshold and this level's wrong, let's have it do something. And that could be defined by anything you want. It could be text messages, alarms, alerts, or physically shutting off a service or modifying the way the service works, because we're now at the session layer with the Series side of the Maestro session controller. So how do we do that? How do we do it quickly and nimbly? Well, the first thing we do is we try and do everything via data models and triggers with it. It's fairly straightforward. You design the data model that you want to keep as actionable points or important and pertinent points to the system or process that you're monitoring. This is really small. It's just there for illustrative purposes. The example of that is each item breaks down into particular trigger points, and at the end of the day, I want to be able to walk through the data model and do a yes or no based on the parameters that are in there, logically, without coding, but with the data. From the KPIs, from the data I pull from traffic and usage studies, Wi-Fi consumption, et cetera, whatever the case may be, just set up a data model for it so we can put that in there. Next thing is I have to socialize that data model to everybody else. Because if they don't know what the process is and how to control it and where they'll interact with it, you're not going to get that full circle loop of action, item, response, challenge, and success or failure with a particular task that you're monitoring. So here is an example where we have different calling plans set up where you wind up configuring these fraud and alert levels based off the data model. The previous screen we had, which had levels for particular countries, et cetera, set those volumes, set those trigger points, link them up to the product and plan, you turn it on and test it. Testing's simple because you just send the message back, get a response back through the series and the Kansys system, they talk. And now you know this is going to do what you want it to do. Your testing cycle isn't 16 months. It's not a bunch of custom coding. It's a series of let's make the rules, let's visualize how we're going to utilize them, and then let's push that full circle. Initiation of a session, a call, an event, process it, track it with the rules, goes against these triggers. If you don't like the triggers in the data model, it's simple. You go in and change it, visualize it again. Everything's a kind of a yes-no scenario when you're talking at the network layer to make that control happen. But with the data stores and the data processing, the aggregation, and the analytics engines that Kansys has been working on for years, we're able to then continue to push that data and the responses back out to the visualization layer for business units, revenue assurance, product management, marketing, et cetera. So now I'm going to turn it over to Chris Knight with Series to kind of explain how the series engine now, in conjunction with the business side logic and rules based off of data, metrics, and rules that we can manage through the visualization engine on the Kansys side, can then take that information and help connect, manage, and process real-time your policies, your rules, your charging, your billing, converged networks, legacy equipment, how we can make that signaling all work together in a more cohesive and cost-effective manner to deploy that and to manage it over time. So, Chris?
Good afternoon, I'm Chris Knight. So I'll be following on from what Brian says about how we collect this data. So all these business analytics, they're only as good as the accuracy of the data and the timeliness of the data. So for example, if you're detecting fraud, the fact you find out it happened yesterday, you've probably lost a lot of money already. So as everybody knows, the volume of data is increasing. People are using video and smartphones and what have you. We have multiple different types of networks. So, the big data concept means really a lot of data, and that data is growing. And the challenge, as I try to show my little graphic there, is how do you take all this big data and turn it into what we call smart data so we can analyze it? So the role of series in this is really to be able to be the interface to the network, to provide the data in a form and in a time that enables these analytics applications to work effectively. So this is kind of a high-level view of what we call our data controller. So as part of the series solutions, we have two main products, one which we call the signaling controller, which works on the signaling plane and the protocol plane, and can actually, involved in the signaling as calls get set up, as data sessions get set up. And then we have a data controller, which is more collecting data from different network elements, and that's this part here. So what we can do is, we can be deployed in a distributed node architecture that allows us to go into different types of networks. So we can be distributed in sort of broadband IP networks and collect data from there, from 2G, 3G network elements. And the challenge is always, how do we collect the data? And generally, each network has its own architecture, has its own set of protocols, has many proprietary ways of doing things. So, so it's hard to have one analytics program that will, be able to collect all the data from all the different networks, without such a solution. So we have our data controller. It's really on the southbound interface. It connects to all the different network elements, whether they're 2G, voice, 2G, data, 3G, LTE, etc. We can collect the data through various interfaces. And then there's a couple of things we can do with it. We can either, so those analytics applications which are truly real-time or pseudo-real-time that needs to be able to do things immediately, we can route the data directly to those applications. Other types of analytic apps will be more historical. So we can store them in a big data store, big data grid, and allow them to be collected at a later time to be able to be processed. So that's sort of the funnel there. We can collect it from any network, collect the data. Within our data controller, we can also filter the data and normalize it, and then route it to the correct application. Is anybody doing big data today? Is this new? Is this old hat? Is it? So nobody today. Interesting. Okay. So I'm not going to go too much into an architecture, but I'll give you an idea of the sorts of things that we're doing inside the data controller. So as I mentioned, on the southbound interface here, we are collecting the different types of data. So those could come in different forms depending on which network we're talking to. So we can talk to broadband networks and collect what they call net flow, which is information about data that's flowing through the network. We can control it through open flow to be able to reconfigure the network. We may be getting, just Ethernet packets, which are just mirrored from ports on different network elements. We might be collecting SNMP traps for alarms that are happening on certain events. We may just be receiving data in, standard packets over UDP or TCP, which are somewhat proprietary. So there's a lot of different data sources with a lot of different protocols, a lot of different transport mechanisms. And the role of sort of the bottom end of our data controller is to be able to collect all those together. So once you've got all that data, then what do you do with it? So there's a number of key functions that we do. The first one may be to normalize it. So you're receiving 2G data and 3G data information coming in different protocols, but it may be the same data that you can just normalize into one common form. So first thing to do is normalize it, and then maybe also reduce it. Maybe you can define some rules. So we have a rules engine there that allows you to define which particular type of data, which type of packets, which fields in which data are really of interest to any given application. And then once you've filtered it, then you want to be able to deliver it. So we have also a routing capability. So you may have analytics applications over here that are interested in real-time alarms and want to get alerted when a certain alarm happens, a certain frequency, for example. So that will be delivered immediately. There may be some fraud detection algorithms that require a certain amount of data in pseudo real-time, so that comes that way. But then maybe what do you do with the rest of the data? So one of the options we have is we can store it in a big data store. So it's it's in the cloud, it's infinitely expandable, and it's there for when the analytics apps wants to be able to go and collect information about whatever it's doing. So that's really at a high level what the data controller is. We're sort of an engine in the network that really provides the analytics apps with the data they need, when they need it, and be able to control and get a handle on all this big data. So here's a particular use case that I personally was involved in. And it was a network operator who was saying, so I've got this network, and it's 2G, 3G, about to roll out LTE. And without adding a lot of extra probes in the network, I want to be able to get the following types of information. And it was things like, they want to know how much data is going uplink and downlink to all the devices in their network. And also a handle on the signaling as well, particularly when you get to LTE. There's a lot of diameter signaling, and one of the big issues right now is how to handle that explosion of diameter signaling. They want to know the users connected on the 2G, 3G network, and what handset they have, and where they are, and that sort of type of information. But then not only that, but they now want to know what are they doing. What are the top 10 URLs that people are accessing? Are they doing audio or video or transferring files, or doing email, etc.? And they didn't have the infrastructure today to be able to do that. So we were able to propose a solution that could sort of integrate in the network, collect data from different feeds, and make it available to report an application that could generate this type of data. And really what that meant was collecting data, some of it proprietary from different sources. So this is an example of a solution we proposed, which was really a centralized solution. So here was, this shows the 3G data, collecting 3G data. So we had a couple of different vendors, each with, in this case, we were collecting some CDRs. A lot of that information can be collected from the CDRs that was already being generated. But guess what? So one vendor had extended, the data that was inside the CDRs to include some proprietary stuff, and the other vendor did similarly. So we were able to, being vendor neutral, we were able to, support both of those interfaces, collect those CDRs. We had the same sort of requirement here to generate reports, but also collect the data for later analysis. So we put it in a big data store as well. And also we were able to hook into one of the real-time elements, the diameter signaling router, to be able to collect information about what's happening through diameter signaling as well. So this is one particular use case where we're collecting data from existing elements. And we actually proposed a couple of solutions. One was a centralized and the other is distributed. And each of them have benefits. So the idea being that you could co-locate the data controller, and it really depends upon the volume and the type of data. You can distribute it out in the different regions, or you can centralize it. But at the end of the day, it gets delivered to centralized applications and a centralized data store / data grid. Now the other half was the signaling controller. So Brian mentioned some use cases, particularly related to fraud, where you may actually be able to cut off users. So once you detect the fraud in real time, you can actually stop the next call. Just collecting data isn't the way to be able to do that. You have to actually be in the signaling path. So we've got different scenarios where we can be in the signaling path to be able to, we may be on the diameter signaling path for authentication, or we could be, a SIP signaling path for call setup for IMS or voice over IP. So once we're in the signaling path, we can actually control whether the call gets set up or not based on some, the output of the analytics data to be able to say whether or not this call should be allowed. So, once we're in the signaling path, not only can you mine data from the interface to feed into this, so for example, the registrations at an HSS or queries to an HLR, but we can also, prevent them, get more proactive and prevent those as well. That's really leading into this one, that, as part of our signaling controller, we can really fit into, again, any type of network through pretty much all the protocols that you'll come across, whether they're SS7, legacy SS7 protocols, whether they're, IMS, LTE protocols. So whether it's, WIN or SIP or diameter or radius, we can hook into those on the southbound interface. And then we can talk to pretty much any application on the northbound interface. And, sometimes this means, interworking different protocols with similar data. Sometimes it means taking one trigger from the southbound and invoking multiple applications to provide an integrated function. So this is one way of delivering that sort of converged charging as a service that Tom was talking about right at the beginning, is that, the idea about charging is that, operators typically have multiple different types of service, whether it's 2G, 3G, whether it's Wi-Fi, whether it's broadband, and mostly you end up with a different billing system for each of those, and each subscriber needs a separate identity, and they have a different balance, and generally get a bit different bills. So the idea here is to have one centralized billing system, converged charging system, and then be able to use that in any of your networks. So let's say you've got a 4G billing system that supports diameter. Then you can use it across all the legacy networks to allow, we will do sort of interwork into diameter, whether it's map to diameter or radius to diameter. We can do that to allow one service to deploy to multiple networks. That's the converged charging, and then also the converged policy as well. So policy and charging, do tend to go together. So the idea of the series network solution is really, we can hook into any network, whether it's the signaling layer or the data collection layer. We have policy-defined rules that can then deliver it to different applications. Any questions so far? Yes, question.
Sorry, multiple questions around one theme.
Okay.
Kind of relates to something I was asking before. If I understand, you're using probes out there in the network. Like, so you're accessing the southbound interfaces. Are you using TAP?
So not necessarily probes, no.
Are you using taps on the interface?
No.
What are you using?
So it depends. So if I go back to, so in this interface here, we're actually physically connected. So on the signaling controller, we're actually physically connected to the signaling path for each of these. So we will be.
On the SDP, for instance? On the call server or the SDP server? Or?
So we could be connected to an SDP. Yep, that's one deployment scenario. So signaling controller with SS7, we will be either an endpoint. We'll have an SS7 point code, and we'll be an endpoint or something like that.
So it's a duplication, then, right? Or is it routing through your service?
Think of it more as a routing. Yeah,
It's a pass-through.
yeah. So instead of say, the network element dealing directly up here, it comes through us. It thinks. We look like an SCP or an OCS or whatever.
Right, so it's routing to it, that's where you're picking it up.
Yeah. So we're in the signaling path on that one. Yeah.
Right, okay.
On the data controller, we're more, we're hooking into an existing interface, whether it's a CGR, whether it's a CDR interface, or we're getting mirrored ports, or we're getting. So there needs to be some way to get the data to come into us.
Right, obviously performance issues on mirror boards, so you probably want to go to the TAP solution instead. Because there's a lot of risk I see in the solution, in the architecture.
Mm-hmm.
Like for instance, have you tested on any of these tier 1 operators with the volume of traffic? It's just so incredibly huge. I was in Japan last year with SoftBank, and they took out their policy controllers because there was so much traffic they couldn't handle it. 16 policy controllers. Ericsson sold them, had to be taken out.
So they stopped doing policy? Is that what you're saying?
No, they reverted to the individual nodes, right? And they had their own policies on the individual nodes. The PCRS were taken out, right, on the LT, for instance. But there's a lot of performance-related issues, and whether there's a benefit, I don't know how you guys measure the risks on this, but the benefits given by the system as opposed to the impact created by the system. Because, for instance, like I mentioned, the issue of policy controllers, it's very hard to do real-time calculation on that.
Yeah.
Around in a very big volume network.
Was that an LT network? Or?
Yeah.
Yeah.
Yeah, and
I mean, was it the diameter signaling? I mean, taking out the PCRF, did they take the PCRF out, or they took out like a DSR or something in the middle?
yeah, that's right.
Which one?
Sorry, they took out the PCRs themselves.
They took the PCRF.
Yeah, exactly. Yeah, so they didn't went to another. They did it very differently after that.
Okay.
But Ericsson's solutions didn't scale, so then this.
Right.
World's best, right?
Yeah.
It's just
So they say.
Yeah, so they say, right, right.
Yes.
It's just scalability. Now, is your system software-based or hardware-based?
Software based.
So
Yeah.
of course, then you have the software-based limitations because software cannot process as good as hardware, but you have more control.
Yeah.
Um,
Yeah.
And then I guess you're tapping into the camera interfaces as well.
We can and do. Yes.
Now,
Yes.
there's one critical thing on the security aspects because our company deals a lot with the security in there. So if you're actually enabling on the signaling layer to take out information from there, you're bypassing a lot of 3GPP security protocols. So, for instance, how are you tapping in with if you don't have the keys? And if there's, let's say IPsec on the line, there is a lot.
So when it comes to the signaling controller, most of these are deployed in the carrier's network. So they're within their trusted domain, if you like.
No, right.
So when we're hooking up a camel, we're not bypassing.
Say, let's say the, I don't know, GX interface or something like that. Between two nodes, you'll have maybe the certificates, right, that are exchanged, or go to an ESS system where only a trusted node can authorize into there. So I guess you guys are included in this trust.
That's right. Yeah. Yeah. Most
So you have
all of these are deployed by the carrier in their trusted domain. Right. So
certificates you can carry them.
yeah.
stuff like that.
Yeah. Yes. Yes.
Yeah, because there's an issue. There's a lot of these interfaces are secure, and if you bypass the security on them, you kind of obfuscate the risk. You take out the risk, and then
Oh, for sure. Yeah. Yeah.
you increase the risk.
Yeah. Yeah, security hasn't been a problem. I mean, the point you raise about performance and latency, obviously, needs to be considered. Putting a new element in the network between, the client and the server, if you like, introduce a latency. But we haven't seen that specifically as an issue in our experience so far.
There's also a lot of talk about data ownership, and when you introduce new systems and new vendors, you're introducing another layer of data ownership and therefore data responsibility.
Are you thinking specifically when we, in hosted solutions, or?
Yeah, like cloud solutions. for
Yeah,
instance,
yeah.
If you take data out of the network,
Yeah.
you have to become data responsible.
Mhm.
And there's a lot of private data. No one knows what's going to be going on with that. How do you get around that?
Brian, any comments on that
Well,
one?
most of the cloud data that we're using today will either be, depends on whether you're going to keep part of the data hosted within the carrier's network in and of itself, proprietary customer-facing information or data. Another item is the sanitized analytical data that you may send out that has nothing to do with any customer-facing information that passes any kind of compliance issue as far as anonymity to the data elements themselves. So you can generate models with the data as far as what you're willing to exchange and whether you need to put an obfuscation layer in there between the visualization and then the core data in the background. So you can manage that in the cloud layer as well as in the infrastructure from the host networks that have like carrier CSR information, customer account information, that kind of stuff.
But then now see with this convergence of IT and telecom, there's a very huge risk. But the whole trust relationship that customers have with their operators are that they know it's been traditionally a proprietary network. They have trust that this network has never been broken traditionally before. And now with the introduction of saying, hey, we can take some of this data outside of the network and play with it, this kind of reduces reduces that trust, would you say?
Well, you
So
can
I
also
want-
deploy the cloud infrastructure, if you will, internally and keep it within your own borders.
Yeah, I mean, it's not as if
So
we're
that
putting
it
this on the
follows the same
internet,
policy.
everybody can access. It's,
Right, but as
Yeah.
soon as you introduce that layer,
yeah, yeah. Yeah, I mean, and there's regulatory requirements as well. I mean, sometimes it's hard for us to get, access to some of the interfaces we need because, within inside the operator themselves, they can't share just simple traces. So, yeah, it's an issue. It's an issue for sure.
Yeah, you can always see everything you want, but don't look at it. So at some point, you have to come up with that, what's the acceptable relationship there, the visibility to information, the data security, and then, technically, where it sits is germane to ownership rules as to who owns it and what, how you access it, and the methodology of what views of that data you're going to publish out to maybe a less trusted domain, et cetera. Well, those are all data management issues, but you have to make sure you give enough time on how to set it up.
because I had this discussion with actually the arguably largest data ownership kind of industry in the world. Some say Telecom, but some say credit cards. They hold tremendous amounts of data, and they were very specifically targeted towards control and ownership, right? And they have a lot of restrictions on them and regulatory, they're controls. So this is new for telecoms coming in. Now, have you measured your performance on the network? The additional signaling that you guys are creating, your product is creating on the network, and what kind of impact that is? Have you done a risk analysis on that?
Yeah, yeah, yeah. So on the data controller, I mean, normally we're hooking into existing interfaces that aren't related to real time. So that's less of an issue. On the signaling controller, yeah, I mean, we're in real time processing, so we are part of call setup. So, it adds latency, adds response times, but, we,
Additionally, be further equipment needing to be bought, provisioned, and integrated into the system to take, like, let's say you're using 25% of the CPU, 50% of the memory.
Generally, we do run on additional servers, yeah. So even though we're a software-only solution and we can run on pretty much any sort of Linux-based server, Linux Intel server, we don't generally run on existing. So yes, for the signaling controller, we do have additional hardware.
That's what I was wondering about
Yeah.
that. So if you're running on this hardware, then you are going to increase the cost for the operator.
Yeah. I mean, there is a cost to doing these type of solutions.
So
Yeah.
the reward should be proportional.
Absolutely, yeah. So I'll say one of the big things right now is converged charging. So right now, I'm working on an opportunity where this customer has a billing system for GSM, for CDMA, for Wi-Fi hotspots. They've got about 4 different billing systems. So the business case for this solution there is that you buy one integrated solution, so you eliminate your CapEx and your OpEx of running 4 parallel systems. And now you can provide your customers, with one identity and one balance, one bill, and increase customer base that way. So yeah, so that's the business case.
Yeah, and still keep the old systems, of course, because you're creating a single point failure there.
We typically migrate away from them,
Oh, you do?
fast or slow.
Dangerous. Thanks.
Yeah. Yeah, interesting points there. Any other questions? Is this something people see as relevant, or ahead of the time, behind the time, in time? Any comments? Good done?
Okay, well,
Great.
Thank you.
we'll catch you at your booth.
Thank you.
So just a reminder, all these guys will be on the exhibit floor this evening, and tomorrow. So if you have any other questions, feel free to catch them then. We're quitting early. We're ahead of schedule. So again, let me say, if you missed this morning's presentations, they'll be on video on RCR Wireless website in about an hour. And thanks for your attendance, and we'll see you on the exhibit floor later tonight. Thank you, Gary.